Hello friends, today I am going to discuss the chapter vector. Before discussing this, we have to know about two quantity. One is scalar quantity and another is vector quantity. So what is scalar quantity? Scalar quantity having only value or modulus, no direction. That means length, mass, time, energy, work, specific heat. This type of quantity is having only value or modulus, but we need not to know the direction. So these type of quantities are called scalar quantity. And all of you know he is Thor holding a hammer and he is doing a work, but we need not to know in which direction he is doing the work. We need to know how much he is working. So work is a scalar quantity. And the another is vector. Vector is different. It is having value as well as the direction. For vector, value and direction both are important. Some example of vector is um, are displacement, velocity, force, etc. This figure represents the a running motion of bolt, and if we and it shows the modulus, that means the speed, the velocity, and in which direction he is running, it is also important. Now the basic difference of scalar and vector. One is scalar having only value, no direction is required, and vector is having value as well as the direction. And the other important difference is um, the scalar follows general algebraic rule, but the vector follows vector algebraic rule. So I am going to discuss what is the general algebraic rule and what is the vector algebraic rule. Okay, let's start with an example. Say Ram does 30 joule work and Sam does 10 joule of work. Then total work done is 30 plus 10 equal to 40 joule. But now say the example of vector. A car runs 10 meter per second on AB path. This is AB path, and here the car is running 10 meter per second, and then runs 20 meter per second on BC path, and then the car run through BC path at 20 meter per second. What is the velocity of the car? That means what is the resultant velocity of the car? You are thinking that 10 plus 20 equal to 30 meter per second. No, it is wrong. The correct answer is root under 10 square plus 20 square. So how have I done this? Are you interested to learn this? Okay, let's go. Before learning this, we have to know what is the how the angle between two vectors is measured. Okay, let this one is a vector and this one is a vector. The arrowhead is given to direct the vectors. Okay, now this is called the angle between two vectors. Now let's another example. Okay, here one vector is directed in this direction and the another vector is directed inward direction. So how can we calculate the angle between these vectors? Okay, at first remember we have to make the arrowhead always outward direction from a point, then we can calculate the vector angle. So to make the arrowhead outward, we have to extend this vector. Yes, this is the extension. Now this arrowhead and this arrowhead, each outward direction from this point. Now we can measure this angle, and this angle is the angle between these two vectors. Okay, now take another example. Yes, here Two vectors are inward direction, so we have to extend both of them to get the outward direction. Yes. Now we can measure this angle, and this angle is called the angle between two vectors. Yes. Now addition of two vectors. Addition of two vectors gives resultant of those vectors. Let A is a vector and B is a vector. If we add them, we get a vector like R. What is R? R is the resultant of A vector and B vector. So we cannot add them in general algebraic equation. We have to add them by some rules. Basically there are two rules. One is triangle rules or triangle law, and the another is parallelogram law. At first I am going to discuss the triangle law of addition of two vectors. Yes, triangle law. If vector A and vector B are represented by two sides of a triangle, the third side will represent the resultant of these two vectors. Let's this is a triangle, and this side is representing vector A and this side is representing vector B. Then the third side is this. This will represent the resultant vector of vector A and vector B. Yes, this is vector R. This is triangle law. Okay, practical example of triangle law of vector addition. Let this is a box, and on this box two forces are applied. Force means this is a vector quantity. Let one force is 3 Newton and another force is 4 Newton, and both of them are acted at 30° with each other. So we can place the vector quantity, that is 4 Newton and 3 Newton, uh, accordingly on the two sides of a triangle. Okay, we have to place this vector 4 Newton and 3 Newton on the sides of a triangle. So we have to make a or create a triangle, but we can create a triangle through a scale, but in scale there is no unit of Newton, it is having millimeter and centimeter. So we have to represent the Newton unit in centimeter unit. So let us assume 1 Newton means 1 centimeter. That means 4 Newton means 4 centimeter and 3 Newton means 3 centimeter. At first we draw the one side of a triangle which will represent the 4 Newton. So this side will be 4 centimeter. Yes, this is 4 centimeter. That means it is representing the 4 Newton force. Now we have to place 3 Newton having 30° angle with 4 Newton. Yes, I am placing here, and this is extended 4 centimeter. This line, black line, is the extended 4 centimeter, and this angle should be 30°. Okay, now I can add them this. So it is a complete triangle, and this third side will represent the resultant of vector 4 Newton and 3 Newton. Measure it by scale. It will suppose it will give p centimeter. That means the value of the resultant of 4 centimeter and 4 Newton and 3 Newton forces will be p Newton. But now the question, what will be the direction? It will be upward directed or downward directed. Always remember this rule. Resultant indicates the opposite rotary motion. Okay, here 4 centimeter represents a 4 centimeter and 3 centimeter, both of them are representing a counterclockwise rotation. That means the resultant will represent a clockwise rotation. That means the arrowhead will be upward. Okay.